Grade 01, today we'll be discussing low level and high level language.
Okay.
Now, at the end of this lesson, we will be able to distinguish between both languages to have an idea of what both of them are. Now, starting with low level language. Now, low level language actually refers to machine language. Now, this low level language, it actually doesn't require compilation or anything. It doesn't require any special software, not in all cases, to break down any coding, because as it says, it provides little or no abstraction from a computer's instruction set or architecture. And low level language actually is broken in two. You have the actual machine code, and you have assembly language, which is a bit step up, somewhere between what is human understandable and machine understandable. But assembly language is really considered to be a low level language for the fact that it also has some of the same instruction set from the microprocessors that is used for the computing of programs and other systems within the computer. Now, machine code is actually binary language, which of course you may be acquainted with it in first form as the same zeros and ones. That is what machine code is. Now, as states, the reason it is called low level language is that abstraction is virtually non-existent. The language is close to what the hardware of the computer understands.
So, how do we mean by abstraction?
Okay, I was going to go down that road. Now, abstraction. Now, what happened is that high-level languages, which we're going to go into, has some amount of that, because machine language consists of zeros and ones and some amount of data that represents actually what hardware understands. For the sake of ease, high-level language was developed to have a more understandable framework, something more close to English that we can relate to. Because if I have a bunch of zeros and ones here listed on the board, which we're going to get into down the road, you're going to find how hard it is to comprehend machine language. But we're going to go into it.
Okay.
Now, as I state here, that it doesn't require compilation. The logic runs directly on the processor, because this is what the computer understands. And as stated here, it runs very quickly. That's one of the advantage, because it don't require any special software. It runs very quickly. The reason why machines compute things in zeros and ones is simply that if you look here, all of this here, what this is GPS current. Now, what happened is that when the GPS current hits a computer like this, it goes into what is known as the power supply, which is what helps to provide the computer power to operate. Now, what happened is that the power supply breaks down the alternate current from GPS into the DC current. And that is from where now the computer, which is direct current, and that is from where now the computer breaks it down to zeros and ones, which are on and off state. So just like we see this slide, it reads as on and off state. Like for example, let me use the analogy of this light switch. So it reads it as on and off state. So that is how the computer actually reads the current, because how the current flows, it flows like that in on and off state. And that is how it reads. So every off state is a zero, every on state is an on. And that is why the computer actually, that's how the computer actually processes it when it actually flows. You may not necessarily see the on and off because of course that current flowing straight, you have straight light. But actually that is what happens. So it goes into the computer then breaks it down, the microprocessor to be exact, breaks it down into on and off state. And when we'll actually get on to algorithms, this is one of the reasons why typically, and probably going to the degree, you recognize that never ever you use two machines to run an algorithm. Reason being is that, or rather use the same algorithm on two different machines. For example, look at Windows 95. You remember the old machines that Windows 95 come on? As opposed to these newer technology. Looking at this was made after the year 2000. So you will find that these machines possibly have like a Pentium processor, which is a more advanced processor. So you find that this can process data faster than the computers of older
What is the
time.
name of Pentium and so forth?
Oh, okay. That is actually the name of one of the processors. When I mentioned processor in the slide before, that is what processor is. It is actually like the brain of the computer. Taking back, of course, from what you will learn from about the operating system. Now, high-level language, on the other hand, is something more like human language. So you find that it has more abstraction. So it has representations of internal instruction set that the computer would understand. So it put it more in a human readable form.
What's abstraction mean? Human readable form?
Yes, put it in a put it in a form that we can more relate to.
Oh.
Exactly. And this is why, and this is what distinguishes it, that it don't seem like gibberish to us. Because of course, you know, foolishness by definition is something you cannot relate to. So instead of having it seem like foolishness to us, the software engineering team, you have the IEEEs that they come forward to put forward systems and programs to have something that we can relate to, something that we can easily map and comprehend. So you find that it may use natural languages, easier to use, automate, significant errors in computer systems. So you find that here, that it is more, see the key word I said before, understandable.
Oh.
And that is what, and this is why high-level language came into place, to make things more understandable that we can actually relate to. Okay, and now these are actually some of the languages that came as a result of the developing programming language. Some of these we're going to get into in more details in next lesson. So you find that more abstraction here, and because of the more abstraction, more human readable form, you find it now, you now need specialized software to then to break it back into a language that the computer can understand and easily relate to. Now, I'm going to be, can class, can you see this? If you can't, I can pull up a bigger slide. No.
We're trying to see too.
Not readable. Codes,
Small, sir.
small, but, okay. Let me
I
try
can understand sample Pascal code.
Well, you can say, okay, let me definitely bring up something here. Now, let me wind this. Now, this is an example of a high-level language. What is here? Now, as you can see here, readable. Most of these things, even without necessarily being a program, you could actually understand. Words like begin, words like end, right, and then which mean. So now,
I think I'm finished with my
we're going to now be demonstrating a high-level language versus a low-level language. Now, this is actually an example of assembly language code. You know, as I look at it, it is not very readable, as you can see. Just to bring if you can't see clearly, I do apologize. Yeah, so you find that looking at this, it is not very readable. Now Now this kind of code, now this seems to be more human readable.
Okay.
And now this actually brings a distinction between high level and low level languages. High level languages are more human readable, machine languages are more machine readable. So you find that they have to develop high level languages that process can relate to.
Good.
No.
Oh, okay.
And this is actually an example of a ASCII table. Let me prepare a more vivid example here. Yes. So now, this is actually an example of what is known as an ASCII table. This actually now speaks to how the computer itself processes the data in actual zeros and ones. I said null is actually all zeros go across, start 001, and it goes right down. It tells you the octet in terms of assembly language and the verb binary that the computer understands. So now imagine a system that has these zeros and ones instead of having these more readable looking form. You find that persons are easily confused, and this is the reason behind they developing high level languages so a person could relate to. Now, the question that I want to put to you today, is assembly language a high level language or a low level language?
Low.
A low level language.
Why do you say low?
Good question. Good. Okay, why? So because I find the assembly language I put up there, I was trying to understand it in English, and probably the computer understanding it, but I'm not understanding it. So I think it's more for computer.
Exactly, and as you can see that if I bring you back to the same example, you have to go back to actually specify the kind of microprocessor that needs to be used. So it really shows that it was never portable. Because one thing is that every computer breaks down information differently. It is almost like I teach in this class. I can teach one lesson, but every individual, depending on how well it is taught, can leave out with their own interpretation. And this is the reason why they actually had developed a high level language that it can be portable across medium. And this is my lesson for today.
All right.
Thanks for coming.